a function with multiple pieces. Now, every line is a piece. So this first function has a piece that is going to be from an interval of -3 to 0. So I got to grab my pencil. With the interval notation, it's obviously always on your x-axis. So sometimes what I like to do just to kind of show me where these different sections or these different pieces are going to be, between x of -3, -1, -2, -3, just a very light vertical line up till 0. That's going to be the first piece is going to fall in that interval. And then the next piece is going to fall between 0 and 1, 2, 3, 4. So two pieces, one in this first section, one in this second section. Look at both pieces just because. What type of piece is that going to be? What type of function is f of x equals x minus 3? And to be honest with you right now, you guys only know 3 types of functions: linear, quadratic, and absolute value. So what's that one? Linear. It's got that mx plus b format. It's linear. And what kind of function is that? Linear. So you're going to have a little section of a line and a little section of a line in between each interval. Now, the first method of doing this is really just to create a table of values. So when x is -3, which interval does that fall in, Jack B, the first or the second? The first. And so to find the y coordinate, you plug that -3 into the first section. And -3 minus 3 is -6. Which interval is -2 in Lucas K?
X minus 3.
Still the first. So -2 falls in that span. -2 minus 3 is -5. -1 is in that span, so that's the equation we use for that piece. -1 minus 3 is -4. 0. Which one is 0 in? This one is worth discussing. What do you think, Angie? Is 0 in this interval or this interval? A or B? I see why you're saying both, because it's clearly showing up in both. But which one really contains it and why?
Would it be the second one?
Why?
Because
it is the second one.
it starts.
Well, but by that logic, you'd say, well, that's where this one ends. Help her out, Chloe.
Because one of the things is underlined underneath.
Right, this one says 0 is less than or equal to. So this one includes when it actually equals 0. This one does not include 0. Okay? Now, 0 as an x-coordinate is going to be an endpoint for this one, but it's going to be an open circle. Do you see that? Because 0 is not included. 0 is going to be an endpoint x-coordinate for this one as well, but it's going to be a closed circle. Does this make sense? Yes? So, on our table of values, we actually plug into this one. 1/2 times 0 is 0 plus 4 is 4. And I'm going to actually do a little break there because this is really where our piece changes. If I had plugged 0 into the first one, what would it have been? -3, right? And 0, -3 is sort of going to be a point on your graph. It's just that it's going to be an open circle. So we're at least ready now to do our first piece just by plotting these points. -3, -6. Open or close circle on the -3 endpoint. What? Close, because it uses that or equal to. Then -2, -5, then -1, -4. And then 0, -3 to finish out this line is an open circle. And just, we connect those. And then all the rest of these points here, 1 through 4, are absolutely in that second line. So you plug in that. If you plug in 1, you're going to get 4.5. If you plug in 2, you're going to get 5. If you plug in 3, you're going to get 5.5. And 4, you're going to get 6. It's definitely always worth talking about. Are the endpoints of this second piece going to be open or closed circles or one of each? Closed, both closed, because they both use less than or the equal to. So 0, 4 is a solid. 1, 4.5, 2, 5, 5.5, and 4, 6. And everything there is solid. And there's your piecewise function. Yes.
Could you just plug these equations into your calculator and pull up the table?
Yes, of course. Yep. You could. Go ahead. Sierra, what's your question?
Do you have to label the lines?
No, the whole thing collectively is f of x.
Okay.
So that is this function. You do not need to label each one separately. Nope. Okay. Now, the next question is to state the range. And actually, it didn't ask it, but we're going to do the domain as well. The domain is all the x values that are going to get touched. So left to right, starting with -3. Does every x value from -3 all the way up to 4 get hit? Or do we skip anything? What do you think, Tess? Do we hit every x value between -3 and 4, or do we skip some x values that don't have a point associated with it? We do hit them all, correct. So -3 with a bracket, because that's included on the one end, and 4 on the other end, also with the bracket. How about the range? The low to the high, the lowest is 1, 2, 3, 4, 5, -6. The highest is is +6. Do we hit every single y value between those two, or are there any y values that we skip? What do you think, Natalie? We skip some. So what do we skip? What y values do we skip? Say it again. Not -4.
Oh, -3.
-3. And between 4, correct. So our range is going to go from our -6. Does it actually include -6? Yes, so with a bracket. Up until -3. Does that include -3? No, because that's an open circle. And then we're skipping some space, so you use your little union symbol, and then our range is going to pick up at 4 with a bracket, because that's a closed circle, and it's going to end at 6 with a bracket, because that's a closed circle. Tricky, right? Okay? Now, totally new function. We're not going to look at a picture of this one. We want to know when this function equals 1. Well, this function has 2 pieces. So we actually, believe it or not, have to set this one equal to 1, and we have to set this one equal to 1, and we have to solve both of those. Does that make sense? Okay. So the function, which the one piece of it is -2x plus 10, has to get set equal to 1. And then the other piece of it also might equal 1 somewhere. So when we solve those, we subtract 10 from both sides. And I'm going to stop after we solve this one, because there's a thought process that I can't really document that has to occur here. There's no real work that I can show, so you all need to listen very carefully. This particular function, the first piece, will equal 1 at an x value of 4.5. Does this graph even exist when x is 4.5? No. So even though, like, if you think about this, function, negative 2x plus 10, if this is 10, negative 2x plus 10 would normally look like that. So it would hit, did I do that wrong? Yes, of course I did. I did a positive 2 slope, and it should be a negative 2 slope. Hold on. Here's what the line, if it was just the line, and the whole line, here's what negative 2x plus 10 would look like. So that line would cross 1 at 4.5. That would happen. The issue is, though, the piecewise function only wants to see this line when it's less than or equal to 0. Well, here's 0. Yes? The piecewise only wants to see it when it's less than 0. So the reality is, and it's equal to, so I'm using a dot, a solid dot, the piecewise is really only looking at that portion of it. So does that portion of it actually ever equal 1? No. Do you see that? And that shows up because you get an answer that's out of interval. So we actually reject that one. The 5x minus 1 portion, if I solve that, add 1 to both sides, I get 5x equals 2. Divide by 5, I get x equals 2/5, which is 0.4. And then you want to see if that piece even includes that x value. So 0.4 on the 5x minus 1 graph, because that's one we're looking at, does that fall in that interval? Yes. So there's the answer. Find all solutions. It could have happened twice. If that one had given us an x value that was less than 0, we would have kept it. But we didn't because it was out of interval for that piece. This one is in interval for its piece. So visually, what this looks like is the graph of 5x minus 1 looks something like that if it's not part of a piecewise function. That's the entire graph of 5x minus 1. And it does equal 1 at an x of 0.4. So at 0.4, it does equal 1. The piecewise graph, however, only wants to see the piece of this function that's greater than 0, which means to the right of this. So the piecewise function cuts off the part that's less than 0. It only keeps the part that's greater than 0, which does happen to include crossing a y value of 1, which is why that one stayed in the game. Does that make sense? Okay? You'll be doing that a lot, and that's a concept that probably did not get touched upon in Algebra 1. You probably just had a little introduction. But it's like this quirky little thing that you have to think about when you're solving piecewise function equations. Okay, flip to the back. Okay. Determine the y-intercept. So one of the things that you have to memorize, and shortly here we'll start creating some flashcards with quick facts that no questions asked, you just need to know. And one of those would be, how do you always calculate the y-intercept? Algebraically. What do you do? Okay, can you tell me what every point on the y-axis has in common? Chris?
X equals 0.
X coordinate of 0. So for any y-intercept calculation, algebraically, you set x equal to 0, and whatever y coordinate pairs with that is going to be your y-intercept. So in part A, on a piecewise function, when we're trying to determine the y-intercept and we're plugging in an x of 0, you have to decide which interval does that apply to. If you're plugging in x of 0, is x less than 2, Morgan? Or is 0 less than 2, rather?
Yes.
Or is it greater than or equal to 2? It's less than 2. So it fits in that interval, so that's the piece that you plug it into. Okay? You have an advantage when you're plugging in an x number that you already know the x number, because you can just figure out which one it goes into. It can only go in one of them. So you plug in a 0 for the appropriate piece. and you get 5. So what is the y-intercept? 5. Why can a function have only one y-intercept? And I'm going to plot this y-intercept, by the way, 1, 2, 3, 4, 5. What would be the problem if this function had another y-intercept? Georgia?
It wouldn't pass the vertical line.
Perfect. It wouldn't be a function. Okay? If I had another point here that was also on the y-axis elsewhere, we'd fail the vertical line test, which is why you really only have one interval to plug it into, that x-coordinate of 0. Okay? Finding the x-intercepts is different, though. I can have multiple x-intercepts, correct? If I have a point over here and a point over here and a point over here, I could have 3 of them, I could have 100 of them. I'm not failing the vertical line test. Yes, I'd fail the horizontal line test. So the inverse of it wouldn't be a function. In other words, it wouldn't be a special one-to-one function, but it would still be a function. Yes? So find the x-intercepts is setting y equal to 0. Now this is technically y equals. So you need to solve 0 equals, and you actually have 2 pieces to think about. Does this make sense? When you plug in an x value that you know which one piece to plug it into, and you only plug it into one piece. But if you have the y coordinate of 0, and that's the other one you have to memorize, if you're finding the x-intercept, you set y equal to 0. 0 may equal 5 minus x, or 0 may equal 1/2 x plus 2. Are we all good with the fact that g of x is the same thing as just y? That makes sense? Okay. So when I solve each of these, just like I had to do on the front, I'm going to have to think about, is my answer in the appropriate interval for that piece? And if it is, we keep it. If it's not, we ditch it. So on this first one, I'm just going to add x to both sides, and I get x equals 5. That was from piece number 1. Is x equals 5 appropriate for this interval?
No.
Is 5 less than 2? No, it's not, right? I'm only if this number ended up being less than 2 was I going to keep it. So that's out. On the second one, subtract 2, subtract 2. How do I get rid of that 1/2? I'm going to go with Corey.
Multiply by 2.
Multiply by the reciprocal of 2, correct. So multiply by 2, multiply by 2. The left becomes -4, the right becomes just x. Is -4 in the appropriate interval for the 1/2 x plus 2 piece? Is it? No. So actually, we have no x-intercepts here. And when I graph this in a second, you're going to see why. Okay? So the pieces are getting cut off at 2. So I like to just put a very light vertical line at 2 to show me that prior to that, I'm going to have one piece, and after that, I'm going to have another piece. Starting with the first piece, 5 minus x. That's a line with a y-intercept of 5 and a slope of down 1 over 1, down 1 over 1, down 1 over 1. So that line alone, ignoring the piecewise information for a second, that line would look like that. But the interval tells me I only want to see this when x is less than 2. So here's my 2 line. I only want to see this when x is less than that. So I only want to see to the left of that, which means I erase the other piece. When I just erased that other piece, guess what I erased? What would have been an x-intercept of 5 just got cut off. Does that make sense? That's why we rejected that x equals 5. Do we follow? And we have to always be specific. Is this an open circle or a closed circle? Open. X is less than 2, so make that very clearly open. For the next piece, again, I'm going to ignore for a second. I think this is the easiest way to do it. I'm going to ignore the interval part, and I'm just going to flat out graph the line 1/2 x plus 2. So that's a y-intercept at 2, and up 1 over 2, up 1 over 2, up 1 over 2. And that line, independent of the piecewise function, would look something like that. And now I process that, oh, I only want to see this when it's greater than or equal to 2. So here's my 2 cutoff. I only want to see this on that side, when x is greater than or equal to 2. So I get rid of anything to the left, and guess what? I just cut off the x equals -4 x-intercept. And is this endpoint open or closed? Closed. So actually what was an open circle on the other piece just got filled in, which is fine. So when all is said and done, it is filled in. So you can see there how your 2 individual x-intercepts, if these were full lines, just got chopped off due to the intervals, which is exactly why we rejected them. Does this make sense? All right. Why does your graph contradict the answers you found in part B? And that's exactly it. Because based on the intervals, we had to erase, essentially, those pieces of the lines. And then E, how can you resolve the fact that the algebra seems to contradict your graphical evidence of x-intercepts? We've already resolved that fact from the beginning. Because when we solve these types of problems where you know the y-coordinate and you're solving for the x's, you have to see if that x falls in the interval of that piece that you were working on. So we don't need to write that up, but we've been kind of resolving it from the get-go. All right, and lastly, exercise 2, the function f of x is shown. Write a piecewise function. So we know the graph. We have to write the function. So let's start with this. How many pieces are on our piecewise function? I'm going to go with someone I haven't talked to yet. Alexa. 2 pieces? I disagree. Which 2 can you go up there and point to which 2 you see? This one and this one?
Yeah.
And I think you're missing it because it coincides probably with but there's a flat line right here too. So if you guys could just darken that, it coincided with the grid line so you didn't really see it. Sorry, so there are actually 3 pieces on this one. And I think, so we're going to have 1 piece, 2 piece, 3 pieces, and each equation is going to have an interval. So there's usually a comma after the equation, and then you fill in what interval it goes along. So let's actually start with the intervals for each piece. The first piece goes from here to here. What interval is that, Jack Taylor? Perfect. -8 is here to -2. And let me ask you this question. Does it include -8?
Yes.
Does it include -2?
Yes.
Yes. So, the one thing is about our intervals, you guys, do you notice up here, they're not in interval notation. They're like written in set builder, like with inequality symbols. So you would say -8 is less than or equal to x is less than or equal to -2. For your first piece. We'll get to the equation of that. Well, let's do it now. And we'll just write the equation of this line in mx plus b form. So the slope of this we should all get. So take a minute to figure out what the slope of that line is, and then I'll call on someone. Vince, what do you think? 3 over 2. If you find some nice points, there's a good point, and here's a good point. 1, 2, 3 up, over 2. So that's, if you're going mx plus b form, that's 3/2 x. Now, this piece, as it has been cut, does not have a y-intercept, right? But what would it have been if we let it continue? So take a minute to kind of count that out. If that line were to continue, what would its y-intercept have been? And I'll call on someone. Sierra with a C. I don't think you understood the question right. Let me say it again to you. This line, if it were to continue, if it hadn't been cut, you see how it would eventually cross the y-axis? Where exactly? How high up? Count. How high up, if you were to continue this, whereabouts would it cross the y-axis? At 7. Is that exactly right, or is that just a ballpark? That happens to be exactly right. Did you know that was exactly right, or were you ballparking it? You what? You counted it. Because we knew the slope was up 3 over 2, up 3 over 2, up 3 over 2 will put you literally right on there, and that is at 7. So 3/2 x plus 7 is the equation for that first piece. Okay? Our second piece, let's first talk interval. Kate, what's the interval for that second piece? -2 to 3. Does that, so we're going to do -2 is something compared to x, which is something compared to 3. Does that include -2? Yes. What's that? Yes. And you said yes because it's a closed circle, right? Yes. The only problem is, you guys, is you kind of, unfortunately, Kate, you have to base your answer to this one based on what Jack Taylor said. Because I can't have it -2 being in both intervals. That's not allowed. Do you follow? So even though, yes, they're both closed, one of them has to be left open and one of them has to close it, because you can't have -2 in both sections. So since Jack already included it, Kate, we have to just say less than. If Jack had left that one less than, we could have said less than or equal to. Do you follow? And now you actually can do whatever you want for 3. Right? And then the next person's going to have to judge on that. Don't move an inch. We still have 2 minutes. So this equation of this line is much easier because it's a horizontal flat line. And when it's a horizontal flat line, it's just y equals whatever number it's going through. 1, 2, 3, 4. So that's just f of x equals 4 for a horizontal line. There's no mx plus b. Well, I guess technically there is, but what's the slope of this? 0, and so it crosses out mx entirely. And then the last function has an interval from 3, which we cannot include because Kate included that in the previous one, to 6. And that does include 6. Now this line has a slope of down 2 over 1, down 2 over 1. So that's -2x. And then we kind of just have to count backwards until we see what the y-intercept would have been. So once I get there, it's 4, 5, 6, 7, 8, 9, 10. -2x plus 10. That's okay. Yeah, yeah, yeah.